The general form of a quadratic equation is ax squared plus bx plus c is equal to 0. Let's use the idea of completing of squares to find the value of x. Now, this is the coefficient of the x squared term. Let's divide through by the coefficient of the x squared term. Now, this is the middle term, the x term. We are to multiply it by half. We have to square it and then add it to both sides of the equation. Now at this level, we just ignore this term. We write this as a perfect square. Now, let's deal with this. Let's simplify this aspect. So our LCM here will be 4a squared. Now to do away with this squared, let's find the square root of both sides. We want the value of x, so let's send the whole of this to this side. Now square root of 4a squared. Now square root of 4 is 2. A squared square root will be a, so we'll be left with 2a. And this is the general.
It's question time!
Solve the following questions using the general quadratic formula.
What we do is that we compare it with the general quadratic equation. That is ax squared plus bx plus c is equal to 0. By comparing, our a is 2. Then our b in this case is minus 3. Then our c is minus 1. Then after comparing, we just state the general quadratic formula or the almighty formula. So in this case, we know our value for b, we know our value for a, and then we know our value for c. We just insert them. So let's do that. Now our x is equal to, now what is the value for b? Minus 3. But here is negative already, so minus 3 plus or minus the square root of b is minus 3, so minus 3 squared minus 4 times a is 2, c is minus 1. Now all of these divided by 2 times a is what? 2. So minus 3 will give us positive 3 plus or minus the square root of minus 3 squared is 9 minus 4, so 4 times 2 which is 8, 8 times 1 which is minus 1, so minus 8 will be positive 8, all on 2 times 2 which is 4. So we are left with 3 plus or minus the square root of 9 plus 8 being 17 all over 4. Now this plus or minus, let's separate them to be 3. Let's deal with the plus aspect. 17 all over 4, or x is equal to 3 minus the root of 17 all over 4. Minus 7 plus or minus, yes, plus or minus. Square root of 7 squared is 49. Minus 4 times 1 is 4. 4 times 10, which is 40. All over 2 times 1, which is 2. So x is equal to minus 7 plus or minus the square root of 49 minus 40, which is 9, all on 2. So we can separate them as x is equal to minus 7 plus the square root of 9 over 2. Now square root of 9 is even 3, so x is equal to minus 7 plus 3 over 2. So x is equal to minus 7 plus 3, which is minus 4 on 2. X is equal to 2 goes into 4, 2 times minus 2. So that is for the first one. Now let's do the negative one also. Let me do it here. Now we have x to be equal to minus 7 minus the square root of 9, all on 2. So x is equal to minus 7 minus square root of 9 is 3, all on 2. X is equal to minus 7 minus 3, which is minus 10 on 2. X is equal to 2 goes into minus 10, minus 5. So the nature of the root of quadratic equations. The general quadratic formula depends on the discriminant, and that is b squared minus 4ac. In other words, it is the discriminant that determines the nature of the root of the quadratic equation. When the discriminant is greater than 0, the equation is said to have a real and distinct root. When it is less than 0, the equation is said to have no real root or complex root. And when the discriminant is equal to 0, the equation has real and equal roots. For us to find the nature of the root of this equation, let's first of all compare this equation to the general quadratic equation. By comparing, a is 2, b is minus 1, and then c is also minus 1. For us to find the nature of an equation, we use the discriminant, which is b squared minus 4ac. Now, we have the value for b, we have the value for a, and then c. Let's just input them. So now we have minus 1 squared minus 4 times 2 times minus 1. So minus 1 squared is positive 1, minus 4 times 2 is 8. 8 times minus 1, which is minus 8. We have 1 plus 8, which is 9. In this case, we know that our b squared minus 4ac is greater than 0. And when it is greater than 0, we say it has real or distinct root.